Our problem starts with a bag of marbles and that bag of marbles contains 5 red, 3 green, 6 blue. If the child grabs three marbles from the bag, we want to determine the probability that the first is red, second is green, third is blue, and compare that when you have 1 red, 1 green, and 1 blue, where it doesn't matter what order they come out in. It's clear that we're looking at the difference between when order is important, when it's not important. So our first question says, oops, here we go. When we have our first marble is red, when our second marble is green, and when our third marble is blue. When order is important, we use permutations, and so we have 5 take 1. So from the 5 red, we're taking 1 marble. From the 3 green, we're going to take 1 marble, and from the 6 blue marbles, we're going to take 1. Altogether, we have 14 marbles, and we are going to take 3 of them. Now, if you have 5 of anything and you're going to choose 1, there's only 5 ways you can do that. 3 items and you're going to take 1 of them, there's only 3 ways. And for the 6 items, there's only 6 ways you can choose 1. When you have 14 and you want to take 3 of them and order's important, you have 2,184 ways that you can calculate or determine, 2,184 ways that you can take those items or arrangements for those items. That gives us 90 out of 2,184. We reduce that down and we get 15 out of 364, and finally as a decimal 0.0412. So the probability of drawing 3 marbles in that order is pretty small. It's 4.12%. Now, what's the probability of choosing 1 red, 1 green, and 1 blue in any order? Well, let's calculate that. So we're going to calculate the probability of 1 red, 1 green, and 1 blue marble. 5 items, we're going to choose 1. 3 items, we're going to choose 1. And 6 items, we're going to choose 1. And then we have 14 items, and we're going to choose 3. Now, we're looking for combinations when we choose them as opposed to permutations, so order is not important here. Now, but if you have 5 and you're going to take 1 of the 5, again, it's only 5 ways you can do that, and 3 ways and 6 ways. So our numerator remains unchanged. What changes is our denominator. There are only 364 combinations as opposed to the 2,184 arrangements. So we end up with 90 over 364. Notice our denominator is the same at this point, only 90 is 6 times larger. And so when we reduce that down to a decimal, we get 0.2473, and you can see that that's 6 times larger, and as a percentage we have 24.73%.